Group quiz. There we go. I completed the individual assignment. Sure. Doesn't say did you understand it.
My questions, pretty lengthy today.
And there's 19 of them. Ugh.
There's 19. It's actually not too bad.
Oh, you already looked at it?
Yeah, I'm just about done.
Oh, you're almost done?
I can answer question 3. Because this part I understand. The null hypothesis involves equality. This is like...
Yeah, I was at question 20, so I'll jump down to where you guys are at.
Oh, jeez. Jeez, Nick.
But you just behind.
Well, I was just looking them over, and then I was like, oh, I know this, so I'll just answer it right now.
Cool. All right, so question 3. Which hypothesis involves equality? Null hypothesis. You already said that, right?
Yes, because I understood that much. Suppose the null hypothesis. Oops. I'm just kidding. I'm skipping ahead.
So the p-value is the probability of obtaining a sample statistic at least as extreme as the one that was actually observed. Use this information to answer the next question. Remember that the p-value is the probability of obtaining a sample statistic at least as extreme as the one that was actually observed. When computing the p-value, which hypothesis do you assume to be true?
Is it the null hypothesis? The null hypothesis?
So when you're doing the p-value, I believe it's the alternative, because you're trying to prove that either, well, you're assuming that
you're trying to prove that the null hypothesis is true or not true.
Right.
Okay, that makes. Sorry, this is what I'm talking about. Like, these group meetings are the only reason I'm going to probably pass this class. If we were left to our own devices, we obviously wouldn't be at BYU Idaho, but I would not be passing this class. I would probably drop it. Thank goodness for BYU Idaho learning model.
Yeah, very true.
I'm thankful for it. I don't know how many people are, but I totally am.
Yeah. Because the null hypothesis is H0 and the mean is 10. Use this information to answer the next 3 questions. Which of the following represents the alternative hypothesis for two-tailed test? Excuse me.
It's the alternative hypothesis to mu is not equal to 10.
The C, the third one?
Yeah.
Meaning, okay, so for a two-tailed test, yeah, that means that it can't be greater than, it can't be equal to, or
see, this is so weird that it says two-tailed, and that's not the wording they use on the preparation assignment, so that threw me for a second.
Well, they used it in, like, the videos.
Oh, okay. I didn't get the videos, so.
I know they use it in the videos, so, like, it's really easy, because I know if it's less than, it's going to be left-tailed. If it's greater than, it's going to be right-tailed, which are both one-sided. And then the two-tailed is two-sided, which is the unequal. And the alternative will not be equal, because only the hypothesis is equal.
Right.
Okay, so this goes right into question 6. Which of the following represents alternative hypothesis for left-tailed test?
Which would be less than.
Less than? Is that what you said?
Yeah, and the way I remembered it as well, so I drew out the normal probability curve, the normal density curve, and the left-tailed side. You have the left-tailed and the right-tailed side. The left-tailed side, it looks like the less than sign. And then the right-tailed is the greater than sign.
Okay. So...
I can kind of see that. Okay, so I'm a visual learner, so that helps.
Yeah.
So we're good with putting A, the first one, less than 10?
And question 7 is which one's right-tailed?
So that would be the greater than.
B.
Right.
Oops. Mm-hmm.
And question 8. Remember that we determined the outcome of a hypothesis test by comparing the p-value to this level of significance, or alpha. Use this information to answer the next two questions. What is the relationship, or which relationship would result in a failing to reject the null hypothesis? P-value greater than A, or alpha, p-value less than alpha, p-value greater than z-score, or p-value less than z-score. I know it's not the z-scores.
So it's, if the p-value is not less than A, we fail to reject the null.
Right. So if it's greater than A, it's failing.
So the first one, A.
Yeah.
Okay. See, I told you, you lost me already. You probably feel like we're flying through, and I'm going, huh?
Good. And so which relationship would result in rejecting the null hypothesis? That's question 9.
Which was what
So
is
if p-value is less than A.
Right.
Because that's just the opposite. If you're rejecting it, yeah.
Yeah, because there's no p-value with the z that we've come across yet. So.
Okay.
Okay.
Look at that. We're already almost halfway through.
Yes. This has been great.
But does that mean I understand anything? No. Honesty. Honesty.
Well, it's nice that a lot of it's not involving like math per se. It's more like deductive reasoning rather than working out numbers, you know?
Well, I think we eventually probably might have to, because it talks about doing the same thing, entering the z-score, but the formula hasn't changed. We just have to understand which is the value, or the, what's it called, the X bar is what he called it in the video. In the preparation, going over the preparation questions, the X bar minus the mu over sigma divided by the sample size. So the sample.
We'll worry about that when we get to it.
Sorry. So the sample means, okay. Sorry, I'm going over it, so I understand. I know, like, sorry.
You're good.
Which of the following would be the appropriate alternative hypothesis?
Well, in reading the information above it, an insurance company is reviewing its current policy rates. When originally setting the rates, they believe the average claim amount was $1,500. They are concerned that the true mean is actually higher than this. So,
an alternate hypothesis would be the average
amount is greater.
I was getting there. I just hadn't read the information yet. I jumped to the question.
So C.
You're just so eager, Kim.
Yeah.
So eager.
Well, you guys are like flying through. Okay, which would be the appropriate null hypothesis? The average claim amount is equal to 15.
You got it, Kim. You got this.
First one.
You guys are so kind.
All right.
Oh, go ahead.
I was just going to read the thing. The insurance company randomly selects sample size of 40 claims and calculates a sample mean of $1,650. Use this to answer the next three questions.
Okay. The insurance company assumes the distribution of the sample mean is normal. Is this a good assumption?
Yes.
I would say yes, because the sample size is normal or is large.
Yeah, is it normal? I would say large because it's over than was it 30?
Yeah, it's over 30.
So that's what he was saying in the video too, is because there was one question that talks about 15 pieces of data. He's like, so.
And then we're talking about a sample size as well. We're not talking about a population.
Right.
Oh, right. So are we good with which one are we going with? A or C?
A.
A. Okay, yeah, that's what I've clicked. Sure. Large numbers. Or is that the central limit? Now I'm second guessing myself.
I believe it's the central limit theorem, if I remember correctly.
No.
I know it's not the law of total probability.
Right.
Oh, we haven't learned the law of total probability.
Let's go back just to make sure. What lesson was that? That was lesson 7.
It would have been like 6, because 7 and 8 were basically reviews.
Right.
I'm going to say it's law of large numbers.
Okay. So the distribution of sample means is normal when X, the sample mean or whatever, is normal. Sorry, let me read it over. Distribution of sample means is normal or when thanks to the central sample size n is large. So the law of large numbers states that as the sample size n gets larger, the sample mean will get closer to the population mean. So I think it is the central limit theorem.
Okay, yep, see? Not totally.
No, that's what I originally thought too, because when we think of big sample, I just automatically think like law of large numbers. Like big sample.
I just remember like the central limit theorem, and that was the only one that was even mentioned, I think, in the videos. But I just kind of think of with the central limit theorem, when it gets bigger and bigger, it becomes more normally distributed.
Right.
Okay.
So, which of the following is the test statistic as defined in this lesson? We have the sample mean. We have the z-score. The sigma is S, I believe. And then N for the number.
Sample size.
No, the S isn't that. The S was standard deviation.
N is sample size. I was saying N is the sample size.
Yeah, no, I was thinking of S. Because S, I believe, is the sample deviate or standard deviation in certain things, or sample variance. I just remember there being an S in relation to that.
I think it's okay. Where Z is the test statistic, sample X is the sample mean, the weird U is the population mean, and the weird like A thing is the standard deviation, and N is the sample size. So
okay.
Z?
So Z?
I think it's Z according to that part of the reading in the test statistic part of the.
I am fine with that. I had no idea, to be honest. I was a little confused on that one.
In today, what we should have read for today.
All right.
Okay.
If not, we've got that other attempt. So.
Yeah. We do, and I think we actually might have time for that today.
The historical mean of sales receipts at a grocery store is $150 with standard deviation of 40. The store manager suspects that the average has decreased. She sets up the hypothesis test with the hypotheses. Null hypothesis with mu equals 150. Alternative hypothesis mu is less than 150. She will use a level of significance of alpha equals 0.05. Then she takes a simple random sample of 36 sales receipts from her store and computes the sample means equals 144. Use this information to answer the next 4 questions. What is the z-score associated with this test?
See, you have to calculate here. So The sample mean, this is the 100, no, I'm sorry, this, the mean, or yeah, the mean is 150. The sample mean is 144, correct?
Right.
Okay, so 144 minus 150 divided by 40
Mm-hmm.
divided by the square root of 36.
And I got negative 0.9.
Okay, I haven't quite gotten that far. Just see.
What did you get, Nick?
Negative 0.9.
Okay, I'm still busting out my calculator here.
Ooh, I don't think I got that. So you did 144 minus 50, right?
150.
150.
Or sorry, yeah, 150. Divided by 40 divided by the square root of 36.
Right.
I got negative 0.9 as well.
I must have set my thing up wrong. All right, let me redo that.
Yeah. Oh, okay, let me go back here to see the information. What is this for? Okay. Do we have to put the negative in there?
That I don't know for sure.
Okay. Might as well try. I mean, if it tells me...
That's the z-score that's associated with the equation, because it doesn't say positive. But the z-score would be negative or positive.
Right. And what is the p-value associated with the z-score?
All right, so sorry, for 15, I'd also got negative 0.9. So do we need to put 0, 0 after that? Or
That's a very good question. I wouldn't think so, but better to be safe than sorry.
okay, sorry, that's what I'm going to put. I'm putting negative 0.900. And then what did you guys... sorry, I was behind for 16.
No, you're good.
Looking at it, but I wasn't sure. What is the p-value associated with the z-score from the previous question? So we have to open up the normal probability applet, correct?
Right.
Okay.
And I got 0.184.
Hold on.
I got 0.184 because it's left-tailed.
Sorry, I had to look at it.
You're good.
I had to make sure I had the right part of it highlighted.
What did you get, Nick?
I got 0.184. Overall, it's 1841, but you just round to 3.
So you're just having the left of that highlighted?
Yeah, just the left of the left line.
So I got that.
Okay.
Did you get that, Kim?
I did. Once I finally had the probability applet set up the right way. What inference would you make about the null hypothesis for this problem? The null hypothesis for this, but it was 100.
So its p-value is less than greater than 0.05. Because it's the p-value is greater or less than the alpha. And so I said, because the number that we got, the 0.184, is greater than the 0.05, I said it failed to reject the null hypothesis.
Okay.
Okay.
See, and that's the part I'm not understanding is how that's supposed to work. And I don't know how to have you guys help me on
So yeah, so Nick, you said for that one, you just take the number that we got, the 0.184, and then compare it to the 0.05 of the alpha.
Right.
Okay.
And the alternative hypothesis is supposed to be that the p-value, or it's less than whatever to support the alternative hypothesis.
Mm-hmm.
But if it's greater than, then it fails to support the hypothesis, in which case the null hypothesis is true.
Okay. Fail to reject. All right, 18. What is the conclusion for this problem?
I would say we have insufficient evidence that the true population mean is less than 150.
Yeah, see, that's what I was thinking too. Did you get a chance to look at that, Kim?
Yeah, I was looking at that question, but I'm still trying to understand last one. It's okay. But if we fail to reject the null hypothesis, okay, there's insufficient that the true population mean is less than $150.
Right. Because if we have sufficient evidence, then we've proved it.
Right.
If we have sufficient evidence that the population mean is 150, we've proved that the null hypothesis is correct. If we have insufficient evidence that the true population mean is 150, we're still unsure. But that one, I mean, we know that the population is 150. The only thing that makes sense to me is the third option.
Me too, especially because we're saying it failed to reject.
Yeah. Question 19. There are two types of errors that can be made when performing a hypothesis test. Which one involves rejecting the null hypothesis when the null hypothesis is true?
Type 1.
Type 1.
I went back to our preparation homework, and he goes over the matrix, and I have that written in, so I was able.
Okay, I'll go to type 1.
Yep.
All right, 2 more.
A researcher decided that instead of using a level he uses, one, which other finding will be true? The probability will increase, type 1 will increase, the probability of type 2 error will increase, the probability of the null hypothesis is true will decrease his experimentally scientifically valid. I'm going to say no on the last one.
Yeah.
He was. Wanting to decrease the probability of making a type 2 error. Sorry, I'm going back to that. He was talking about increasing and decreasing the level of significance. So if we wanted the level, like the opposite is true. So if we want,
I would say that the type 1 error will increase because the level of significance has to do with the type 1 error, whereas it's that weird B thing that deals with type 2.
I'm good with that. I'm still trying to understand what he was talking about. He was talking about how if one is one will increase the other when the other is decreasing, and vice versa. And I didn't quite get it.
Oh, okay, wait. So with this, if we decrease from the 0, 5, then if type 1 decreases, then type 2 would go up.
Yes.
So then it would be the probability of type 2 will increase.
Okay.
I can't even find in the meeting really where it even talks about type 2. I should watch the videos, I guess.
Yeah, it was towards the end of the first video.
Okay. So it's the probability of type 2 error will increase?
That's, if I understand it correctly. Because the alpha, the A symbol, is only associated with type 1 error. Its probability of type 1 error equals A, which is the level of significance. Probability type 2 error equals B, or the beta symbol. Now, when one probability goes up, the other goes down. So if B is increasing, then, or if type 2 is increasing, type 1 will go down. And since it's going from 0.05 to 0.01,
yeah, type 2 will increase.
Yeah.
That makes sense to me.
Now, this last one, I don't know.
All right.
What?
Nick, you're the all-knowing.
I try.
All right. Yeah.
You were way ahead of us. Did we finally catch up to you?
No.
I had 3 questions I hadn't answered yet.
If alpha is equal to 0.05, compute the probability of committing a type 1 error around to 2 decimal places.
Yeah, I don't know how to do this one. It's probably really simple, and I'll feel so dumb because I feel like I probably should have known it, but yeah.
Well, I guess we get to figure it out together because we don't know.
Well, let me look at it again. Is it just... No.
Because we aren't given any information beforehand.
Right.
Ability.
Part of me wants to just say that it's like 0.5, like it's 50% chance. But I don't think that's right.
Yeah, I definitely don't think that's right either. Let's see. I'm trying to open up the book.
So far, I have it open and I'm not.
Man, I can really hear that train, Jacob.
Yeah, sorry. I live pretty close to the train tracks. I'll mute myself for a second.
I can tell because I can hear the train.
That was awesome.
I can hear the train through my door, but then it's louder on the camera.
Coming from my screen. That's hilarious.
That's awesome. We don't even live that close to train tracks, and like I would say they're here in Houston. They're out by the highway behind our house that's a couple miles away, and I can hear the train. Trains are loud, so no wonder if you're like right by the train tracks, it was that loud.
Yeah, thankfully they only come about this time every day.
Ours is a lot earlier in the day.
Oh, really?
6 a.m., 7 a.m.
Oh, man. Well, it's a good alarm clock.
Right? Mm. You I want to say it's 5%. I want to say it's 5%. He talks about 0.01 being 1%.
Right.
And it's 0.01 he's talking about. That's 1%. And so it's 0.05. So I'm wondering if it's 5%.
Right, but it says around 2 decimal places.
Okay.
This is so confusing.
I'm sure it's some trick question.
It has to be.
Because I'm not finding much.
I'm not finding anything. Let's see.
And we didn't get any like things that were like use this information for the next couple questions. Just
No. Not that I recall either. Like, I don't remember seeing use this information.
we could have been done by 2. Just kidding.
Seriously.
Would have given me an hour to. I don't know.
Man, and I got like 10% battery life left on my tablet.
You can do it.
And is the tablet what you're.
Yes.
That's sorry.
So if I all of a sudden just leave this meeting, you know why.
Okay, your tab. Are you? Do you not have a power cord that you could plug in?
Not right next to me. To go get it requires me to get up and pull it out the wall near my desk. And I have to like plug it back in later. It's good.
I just was wondering.
Yeah.
People lose things. I usually blame it on mommy brain. It's okay.
All right.
Good reason to go back to school.
So
I have no idea.
Here's my logic. The alpha being 0.05 would be a 1 in 20 chance. So is that, if it's 1 in 20 chance being, I don't know, it's just 5% to me. I don't know.
So that's why I think I would have put 0.05 because it wants it in.
I'm even
decimal places.
I'm even looking at like alternative websites, like seeing if I could figure it out and like.
Yeah, I don't know.
Well, I say not like because it's an interest of time, but because if we don't know. I mean, we're pretty sure on most of the others that
If I get one wrong, I get one wrong.
Right, but I feel like this could come up later, and I want to like know the reasoning behind this.
Yeah.
Well, no, I understand that too, but I'm just saying. So I say we see what we got on the score, and then see if we can't. I mean, because we can go back in, and if that's the only one we get wrong, we can spend some more time trying to figure it out rather than going, is it right? Is it wrong? And then run out of time. I get to go back to my other life in an hour, so this is school life, and then I have the other adult reality I get to go back to. Yeah, that's why I don't understand this because I want to be able to understand so I can improve on my tests because we have how many more tests we have to take before the end of the semester?
We have 3 more exams.
Do we have 3 more exams and then a final, or do we just have 3 more exams?
Well, the thing said was the first of 4.
Do you guys want to just put 0.05 for 5%?
That's what I was thinking, but
yeah, I'm just putting the 0.05.
Yeah, okay, that's what I'm going to put.
I'm saving my answer.
All right, save all responses.
I save them. Go, especially when we're sure. So I'm submitting my quiz.
Me too.
I've already submitted.
What's the verdict?
Apparently, I got question 4 wrong.
We got 4 wrong. And we got it right. Yes. We got 21 right.
Yeah, nice.
See.
So now the real question is, do you want to get 100% and go back and fix 4, which is only one, like, it's the opposite answer because there's only 2 answers.
Right. I don't really want to.
No, because I understand where we went wrong there. So
because I don't know how to do it a faster way besides just writing the answers down on a piece of paper and then going down. Like,
you know what's really funny though is for question 4, originally I put null hypothesis.
Oh, did you really?
I did. And then for some reason I changed it to agree with you guys.
Well, no, you changed our minds, like, because I was saying it's null hypothesis. No, I think it's like something changed in your brain as we were going through this that you're like, no, it's the alternative hypothesis.
It's very possible. My brain changes a lot.
Are you guys going to go back and do it or not? Sorry.
I don't care enough.
I don't care enough.
I want to know, like, why they threw that trick question in there.
Yeah, I didn't like it.
Seriously.
And there's other stuff in here that I'm not understanding. So it's.
Man, it would have been so nice if this was like a Tuesday one because then I could just like go to devotional right now.
Right. I know. I feel bad that like we kind of set it up for like where you and me like pretty much can't ever even go.
Yeah. No, it's all good. It's all good. I mean, yeah, I'm sure something will work out if I need to go.
Yeah,
a short one.
Right.
Well, you enjoyed the one that one day.
Like yeah. I went with a friend and yeah, it was good. Yeah. But if my friend wants to go again, to be able to go again, hopefully the quiz is like really short that week.
Wish us luck, right?
Yeah. So.
All right. Well, if we're not gonna fix any of these because we don't like.
No. But I mean, remotely, that was like fairly easy, at least for me.
I feel like, yeah, for the reading part that I did, for most of like what I understood most of it, and then once you helped me talk it through, it made sense. Yeah, because there wasn't a ton of, like I said, like number math per se.
Yeah.
Yeah, that's why I think I might actually be able to like read through this and go through and go, okay, yeah, I understand that. Prior to having to do the homework.
I kind of want to know which questions I got wrong on the test. I missed 3, and like I don't know.
How many questions were on the test?
38.
38.
Yeah.
38.
Let's see.
So I think I got a 90 or something like that. But there was one question about probability where I was like positive that none of the answers were right.
Yeah. Let's see.
But
All right, well, I'm going to stop the broadcast just because.
Okay.
Okay.